What's that? You're having it. You're excited. You're geeking out how it's recording right now. It can't see you, but like me right now, it could see me. So you can, yeah. And then the microphone's built in right there, and it just records what's ever on the screen. So still, you guys have your privacy. Okay, it doesn't take pictures of you or anything like that, but it just gets me right there in the corner and records the screen. Real numbers. The sign for real numbers is an R with the second line on it. We've dealt with real numbers all throughout our mathematical career, but just the very concept of real numbers implies that there are what kind of numbers? Imaginary numbers. You may say, who cares about imaginary numbers? I say they're a really big deal. And you're like, I already know about imaginary numbers, Mr. Getz. I know that the square root of -1 is equal to I. Well, congratulations. You know that. How about this? Do you know what the cubed root of 1 minus I roots of 3 are? That's a tough question, isn't it? In fact, I could have you look at the entire year for that. I'm confident that not a single person would be able to figure that out on their own. That's a tough question. But by the end of this class, you're going to be able to answer that. Few people can answer that. You'll be some of them. You're going to get pretty smart. Imaginary numbers do have a purpose. In fact, if you see that this fan right now, it is plugged into the outlet. Does anybody know if that's alternating current electricity or direct current? That's alternating current. Direct current is if you're using a battery, like in your cell phone or in your calculator. That's direct current. If we were using direct current electricity everywhere, we would have to have a power station on every block of our city in order to make things work. And alternating current electricity is made possible by imaginary numbers. Okay? So there is application. But we don't have to worry about it today. We start with the natural numbers. Natural numbers uses the letter N for its representation. Natural numbers are numbers that everybody understands intuitively from the time that they're young. Even animals have a concept of the numbers 1, 2, 3, so on and so forth. Animals can even count. But there's no indication that they understand the concept of, what's the number we could add to that one for whole numbers? The number 0. In fact, there's many times throughout history that the number 0 is not represented in number sets. It's a little bit more of an advanced concept to think about the number 0. Integers add in what kind of numbers? Negatives. Integers, the sign is a Z with a double line. We have numbers like -2, -1, 0, 1, 2, so on and so forth. Notice that in our set here, all the natural numbers are also integers, but not all the integers are natural numbers. So if you notice the graphic organizer, that's the way it's building. Rational numbers. What is the root word of rational? Ratio. And ratio makes you think of what kind of numbers? Fractions. A rational number is any number that can be expressed as a fraction. So 5/3 is a rational number. Can the number 8 be expressed as a fraction? Yeah, 8/1, 16/2. So the number 8 is also a rational number. Notice it's also an integer and a whole number and a natural number. Okay? So we have rational numbers. How about the number 0.5? Is that rational? Because it can be expressed as 1/2. How about the number 0.3 repeating? Is that rational? It can be expressed as 1/3. So it is rational as well. Some of you were saying, well, I don't think it's rational because it goes on forever. Irrational numbers are numbers that go on forever, but they never repeat themselves. So rational numbers, we use a Q. We don't really use a letter for irrational, but the number pi would be irrational. It goes on forever like 0.3, but it never repeats itself. There's no pattern that ever develops. The number E, we'll talk about that as the year goes on, is a irrational number. Can somebody else think of another irrational number for me? Square root of 3. The sine of 46 degrees. The logarithm of 9. There's all sorts of irrational numbers out there that go on forever and never repeat themselves. Okay? We like to think about all numbers, not just the nice ones. We like to think about them all. Okay, so let's go to the basic type of problems that we're going to be expected to do for our test. You should be able to take numbers that are in the real number set, be able to express them as inequalities, and graph them. So we're not going to do problem D, but we will look through A, B, and C. I want to write an inequality and graph the set for this. It is currently expressed in interval notation. If I were to start this problem, I like to start with the graph first. I plot 3 and I plot 5. Can you tell me, is it an open circle or a closed circle? Closed circle. And notice how they join together. As you do the inequality, I say x is all the numbers in this number set. How does x compare to 5? X is less than or equal to 5. How does x compare to 3? X is greater than or equal to 3. So this is where I need you guys to lean in and understand something that you just haven't learned over the years. Is this a less than sign or is it a greater than sign? It is both. It depends on which way you're reading it. So notice if I write this, it reads 4 is less than 5 because I came across the smaller side first. If I read it this way, it says 5 is greater than 4. So inequalities are both. It depends on the direction in which you're reading it. So x is less than or equal to 5. X is greater than or equal to 3. See the difference? Very important. Let's go to letter C. How is letter C different? Yeah, you got some parentheses there, and you got infinity. Infinity is not a number, it's an idea. And because you can't point to infinity on the number line, we never use a bracket on infinity. So as I draw this graph, I will simply plot 5, and I'll draw open or closed circle. Open, arrow off to the left. X is all numbers that are less than 5. That's my inequality. That's my graph. What I would like you to do quickly is I'd like you to do B on your own. So you can take a minute here, sketch the graph, and write the interval notation. You can compare with your friend if you need to. Okay, I have the solution up there. Is everybody okay with that? Any questions? Going once, twice, thrice. Please flip it over. Same type of situation, write an interval and then graph the set. I like to start with the graph. -3 to 9. A closed circle on 9. An open circle on -3. And now, instead of providing the inequality, you can see in this situation, you're given the inequality. We want to provide the interval. So the interval will be from -3 to 9. Notice that we have a parenthesis on the -3 and a bracket on the 9. If you could please try letter C on your own. Letter C on your own. Starting to sweat. There's the letter C. All good? Okay, so let's go to the new learning then, okay? Small piece here, but it is new, so make sure you're paying attention. It says to find the indicated set if A is equal to that interval, B is equal to this interval, and C is equal to that interval. And it's asking us to do A union B. And the question right now is, what does that symbol mean? This is a union symbol. And it simply means the element needs to be in one or the other. If you look, you have a different symbol over here. This is the intersection symbol. And that means it must sit in both. Okay? Brecken, can you please give me an integer? 4. Brecken chooses 4. Is the number 4 in A? It is, because A includes all numbers from -2 to 6. So 4 is in that, right? Is 4 in interval B? Yeah, it's in both of them, isn't it? Doesn't have to be in both, just has to be one or the other. Okay, one or the other. Alex, can you give me an integer? Any integer? 6. Okay, 6. 6 is in A. It's also in B. Okay, so that would be part of both A and B. Just has to be one or the other. I'm going to pick a different one. How about -1? Is -1 in A? Yes. Is it in B? No. It's still part of the set because it was in at least one of them. So I think a good way to be able to figure out what A intersect B is to start by making a graph. And I'm going to look at A as being -2 to 6, and then B from 0 to infinity. So A is the numbers from -2 to 6. I have an open circle on -2. I have a closed circle on 6. B is the numbers from 0 to infinity. Closed circle on 0, off to infinity. So, a couple people got lost in the previous hour looking at this, so please just follow along, okay? Is the number -3 in either one of them? No. Is the number -1 in either one of them? Yeah. Yeah, it's in one of them, right? Is the number 1 in either one of them? Yeah, it's in both of them. Is number 7 in either one of them? Yeah, it's in one of them. So all the numbers from -2 on this way, they're part of at least one of them. So my solution set is from -2 to infinity. That is A intersect B. I'm sorry, A union B. I said intersect. Now, skip letter B, I want to go to C. A intersect B. If it's intersecting, it's got to be in both. Is the number -3 in both of them? No. Is the number -1 in both of them? No. Is the number 4 in both of them? Yes. Is the number 7 in both of them? No. So you are only referring to this special area right here where the graphs overlap with each other. that is A intersect B. And so A intersect B, it looks like, is going to be from 0 to 6. So the final thing I want you to do today before you work on your assignment is I want you to look at D and E. Produce a graph of B and C together and identify B union C and B intersect C. Please try letters D and E. Go.
This section
Okay, let's see if you got the right thing. I'm going to graph it. I've got B is from 0 to infinity. I write 0. I have a closed circle. I go off to infinity. And C is from -6 to +1. Now I'm going to draw that in a different color. I'm going to use red. And so as I look at this, B union C, I just need one of the graphs to be represented, at least one. So there's nothing at -7, but once I hit -6, I always have a graph from that point. So from -6 on to infinity. But for B intersect C, I'm looking at where they cross over. And you can see that the black graph and the red graph, they cross over right in this area right there. So therefore, my answer is 0, 1. That is my intersection for B intersect C. Question?
No, it's not a question. It's just something to note is that you really don't need a graph.
You don't, but I have to teach, so.
Yeah,
Yeah. So if you have a different way of doing it, you're more than welcome to. Multiple ways of doing it. Actually, I would say that probably only a fourth of the time I teach something is actually how I did it in high school. But the problem is when I first became a teacher and I taught everybody the way that I did it, people didn't do very well because everybody's unique. So I just try to find the way that works for most people. So, and usually that's it. So anyway, take out your worksheets. So this homework cover sheet right there. Right now, after today's lesson, you are able to do this front side right here that talks about intervals and graphs and inequalities. After that, it's all about exponents and radicals, and we'll be looking at those things tomorrow, okay? So just that front sheet, and continue working on your homework cover sheet, or your entrance worksheet as well.